Okay. Right. Okay, it's just thank you for letting letting me to use your camera for recording. Okay, you can make a win. All right. And please, anyone who are behind this camera smartphone, just let me know if the screen is turned off, because I'm afraid it may, because that's my phone, it may turn off automatically when it's overheat. Okay, just let me know. But I can also see the LED light if it is turned on. But just okay. So now get yourself ready. Okay, I hope that you have all the modules. That's nice. So many components that you have. Did you get this one? No, this Node MCU. Okay. Okay, that's fine. Now we have here the attendance. Okay. Before I explain the flow of the program, the lesson I basically create it for 4 hours, but it all depends on you. If you can achieve or complete the task quickly, so no need for 2 hours. Just assume that we are going to go through 4 hours. Okay? Assume. But let's see. We don't have class right in the afternoon. Okay. Well, let's see if we can fulfill this in just 2 hours or less. Right. Hang on.
And we sign for both sessions. We sign for both sessions.
Yeah. Sign for both sessions. Okay, sign for both sessions. And next, I'm going to distribute to everyone consent letter. So I'm going to distribute to everyone consent letter. So while you are filling the attendance, so fill the consent letter on releasing the use of the recording. So the recording will only be used for assessment purpose. Like I said, I'm going to need it to get certified as a certified adult learners or train the trainers. Yeah. Okay. So if you look at the group, there will be a link to the resources. Okay, the resources. The resources to our workshop today. And here we have the slides, the full slide. You can open the slide which I am going to use for presentation, and then the course outline, and then the lesson planning. I will go through the lesson planning later. And also these are codes from 1, 2, 3, 4 in text, which later we're going to use for the programming. So 1 to 4 is in C++. We're going to use it under IDE. And then number 3 is JavaScript. We're going to use it for app script. Don't worry, we're going to go through it together. Right. Okay, let's see the lesson plan. So this is the course, IoT application, logging DH22 sensor data to Google Sheet using NodeMCU ESP8266 module. So the course we expect will be 4 hours in total. And this is our place. So there are 3 learning outcomes. The first one, basically, you will learn the working principle of the component that required to achieve the main objective, which is recording the data to Google Sheet through internet into the cloud using NodeMCU module. Then number 2, you can know or understand, put together. The requirement. The requirement. Though we have know the principle or the working principle, we need to know the requirements. What are the required? Or the specification. And then number 3, basically, you're going to construct or to deliver. So the final outcome, what happened? You will push the measured temperature and humidity data into the cloud, and then you can see that from the Google Sheet. So as I instructed that you should get all these components. These are the minimum component that you should have. Use the USB cable for connect to the NodeMCU 8266. Version, like I said, 0.9 or 1.0. I prefer 1.0 version, which is small. And then cable wire, jumper wires, and then the Hrd-Tdf. Then you need, of course, hotspot. You can use our smartphone, and then our laptop to do the programming. So now is basically the introduction. We're going to I'm introducing you the lesson planning and schedule. Not going to take more long because later we're going to do the ice breaking. So we'll invite one by one to just tell yourself. Okay. So later we're going to go through the module. Now first is the overview of the NodeMCU, and then the module 2 we're going to set up how to set up the module, and then get to know the IDE or integrated development environment and to program the NodeMCU. Then module 3 we're going to see the working principle of humidity and temperature sensor, the Hrd-Tdf. Then we're supposed to have break at 1 p.m. And then after the break, we're going to see the Node MCU interface, okay, and see how MCU we can inspect the output using the serial monitoring. Then we have module 5 to set up the Google Sheet, and then the module 6 to set up the IoT in the Arduino code, where the final outcome will be sending the data. Then we have a conclusion, and then a quiz we're going to deliver in e-learning to just check the whether you attend or catch the knowledge and the idea. So I introduced myself. So my name is Dr. Muhammad Amri. So from Faculty of Electrical Engineering, University of Malaysia. I have 17 years experience in instrumentation and measurement. Doing a lot of research I will share you in the presentation. So now I would like to now get to know our participant. But beforehand, I have asked our participant to fill up the Padlet. Okay, your name, okay, one here. So maybe we can. Is it okay if we go one by one? Okay, we'll go one by one. So let's set the camera. So if you could pass this around, and then I can stand a little bit, and then okay.
Speaking to you,
Yeah.
Okay. Good morning, everyone. My name is Marvin Benjamin Chivumbi from Uganda. I'm an electrical and power engineer with around 2 years of experience. I mainly do freelance, and I've worked on projects including electrical projects like installation of fuse boxes, assembly of 2000 megavolt ampere fuse boxes. So all those projects are some of the ones I've been working on. I'm here to get knowledge on how to integrate a Node MCU for IoT-based applications. Thank you very much.
Mr. Secunded.
Marvin.
Marvin.
Yeah.
Okay, next.
Good morning, everyone. By names of Semakula Jonathan. I'm also from Uganda. I have a bachelor's in computer science, and have been working as a data scientist as LexTech in LexTech Solutions Limited, and I've been the projects manager. In LexTech, I've worked on some projects like communication aid for the deaf, which is a combination of hardware and data science. So I want to get more knowledge about IoT from this session. Thank you.
Thank you very much.
Yes. Hello, everyone. My name is Joshua Kasiri. I'm also from Uganda. Have a bachelor's degree in computer engineering. I've worked in the solar energy industry, which was mainly working in producing IoT energy monitoring devices, and in this as the lead hardware engineer. And I have expertise in circuits design, design for manufacturing, calibration, and testing. I'm interested in this course, and I hope to learn more about IoT.
Wow.
Thank you.
Yeah, my name is Kudan Lucas from Tanzania. I've been working for 4 years at SBC Tanzania Limited. Then from there, I shifted to Mbeya University of Science and Technology, where I'm working there as a tutorial assistant for 9 years now. I've been attending here so that to acquire knowledge on the IoT knowledge that will help me in case of teaching those students in my country.
Hello, my name is Xie Zi. I'm come from China. I have my background is marine electrical engineering. I want to be a electrical engineering. I hope to learn IoT from this course. Thank you.
Thank you very much. Hello, my name is Jiang Zhichen. I'm from China too. My background is for the railway signal and communication. I'm for the learning for the practical the IoT and instrument.
Good morning, everyone. My name is Wu Jiawen. I'm from China also. My background is electrical engineering. I hope to learn IoT and how it works in practice.
Okay.
Studying on existing protocol. My name is Mohamed Ali. I hail from Nigeria, West Africa. So my background is mechanical engineering. So I've been in the service of my school, known as Federal Polytechnic, Ida, Kogi State, Nigeria. I've been there teaching, conducting practical as assistant chief technologist. This is my 18 years experience so far. I'm here to acquire more knowledge in mechatronics via IoT. Thank you.
Good evening. My name is Mohammed Al-Muskari. I am from Oman. I work at the University of Technology and Applied Science. My background is instrumentation and control, and I'm here for IoT applications and training.
Good morning, everyone. Linet Naziwa. I'm from Uganda as well. My experience is in electrical engineering, 3 years as well. I work for a company called Rila Uganda, and my expertise is in industrial automation and mechatronics. And I'm here to gain more insightful theoretical and practical knowledge on IoT and embedded systems.
Thank you.
Good morning and assalamu alaikum everyone. My name is Hassan Sakif and I'm from Bangladesh, and my background is in electrical and electronics engineering, and I have also been working as a teaching assistant in Primus institution back in my country in higher mathematics. So I'm here to learn, enrich my knowledge on IoT and how to expand the world of mechatronics into different platforms. And I have expertise in fields like C, C++, MATLAB, Proteus, and robotic simulations. Thank you.
Hello, my name is Audition Asia. I am from Indonesia. Well, before I'm taking my master's, I was also a student in UTM, majoring in mechatronics. My expectation here is to utilize transducers with precision and various systems.
Good morning all. My name is Kenneth Ntende. I'm from Uganda, 26 years of age. Prior to my coming here, I'd done my bachelor's in electrical engineering, and I'd done some work under the company of GTech Limited, who were doing electrical and mechanical work. So I was doing more of automation, installation, and some maintenance works here and there. So my coming to attend this course, I want to have a practical experience with IoT and see how I can enrich myself in this field. Thank you.
Hello everyone, my name is Zhang Haoyu. I'm from China. My background is electrical engineering. I have no experience for IoT, but I hope I can learn more about IoT from this course. Thank you.
Thank you very much.
Hello everyone, my name is Wu Shupeng. I come from China. My occupation is electrical engineering. I don't attend work. My practice is lazy and milling machine. Thank you.
Hello everyone, my name is Li Xu and I come from China too. And I have a background of 4-year electrical engineer. And I want to learn something about IoT from this course. Thank you.
Good morning, everyone. My name is Bong Zihao from Malaysia, and I'm currently working as a design engineer in an automation solution provider with the expertise of CAD designs, IoT integrations, and automatic automation control. So my expectation for this course is to gain a knowledge of employment of IoT applications.
Okay. Right. Thank you very much, everyone. Let me put here. Okay. Later. It's okay. About e-learning, I will give it later. So I can see most of you have engineering experience. So that's, I think, what I'm going to deliver is. I hope that that's the best thing I could offer. So in this, basically, we going to need the knowledge, basic knowledge of C++ programming, and there will be some JavaScript, but you don't at the moment you don't really need to know how to code the Java. We're going to give you the coding. We're going to see it how it works. Okay, in the whole process. So, as I said before, we're going to see an IoT application, how to push data, sensor data, to Google Sheet using NodeMCU, basically through the internet. So in this application is quite useful if you need a wireless measurement. And I will show you the research example which I've been running up until now. So we have gone through basically the lesson plan. We're going to cover 6 modules. And then the beginning, we're going to see the concept or the overview of the MCU. And then you have to capture the important facts. So because we're going to review that in e-learning, we'll show you where you can basically quick quiz, 23 question, objective. So you can do it later to measure your understanding on the topics on the training today. So I welcome your basically participation. If you have any question, you can quickly ask. No, don't worry, and then try to going one by one. Okay, later. All right. So we have here our NodeMCU overview. So NodeMCU basically was developed under the community of open source hardware and software. So it is based on open platform or open source. And if you look at the internet, there are a lot of communities like GitHub, A lot of developers are there exchanging ideas on how to use the Node MCU. But basically, if you look at the Node MCU, there is a ESP8266 module. So that is actually a Wi-Fi module. So you can buy it separately. A ESP8266 module. So it is a Wi-Fi module that you can use to connect with the internet and do some application. So ESP8266 has become popular, but the issue is that the initial programming was complex, and you need to be an expert to program the ESP8266. So the developer in 2014, basically in 2014, they build up this Node MCU, and then on the top there has ESP8266. So the word Node MCU means that Node microcontroller unit. Microcontroller. So the birth of this Node MCU, so they are microcontroller together with this ESP8266, so it can connect to the internet. So they're basically the antenna, flat antenna. So they since 2014, so it has release and growth. And if you look at the internet, there are a lot of open source firmware and development platforms. You can find many applications. Even you can find people who are expert and exchange information and knowledge. So the Node MCU, some of the points that we can see that why we prefer Node MCU, it can be easily integrated with many kind of sensors. So we don't need so users can connect and use the sensor without have to think about the intricate setup procedures. So you just need to come with the function, put together and do some testing, and then coding, compiling, you get you get the output. So it can MCU can design to support wide range of sensor for IoT. In this case, the DHT11 or 22. So some of you may get the DHT11 or 22, doesn't matter. The only things different is the pin configuration and some coding declaration. So that we're going to go through that. And other more sensor like say motion sensor, and the light sensor, and so on. And that's why it is developed to be as a unified interface. So this standardize the process of interfacing for sensors. So this when we want to integrate, although from different manufacturers, so but the coding or the process can be the same. So it means the interchangeability is easy. And then it's one of the best one is the cost is effective. So almost everyone can afford to access the use of Node MCU and use it to integrate with other low cost sensor or affordable sensors. And then they offer friendly development environment, and they support popular programming language like Lua. Lua is like different languages like to Java or PHP, which doesn't need compilation. So basically they are interpreted. But for Arduino or C++, Arduino basically use C++. So C++, we have to they have compiler translate the language into machine code, and then run the instruction on the hardware. So it can also be used under JavaScript, similar to JavaScript or to Arduino, so it's C++. And then it can provide real-time data retrieval from our sensor, so that we can monitor our let's say some room which is remote, and then we can see the data anywhere in the world where we can access the internet. Other than that, it is wide application range. It can integrate many kind of sensors together, and also there are good community supports. When you use Node-MCU development, you can GitHub, for example, for instance, or you go to the other community support for programming. They have a lot of people are working on the same module. Now, okay, do you have your with you Node-MCU? So here I have a version 1.0. Do you have the same, or anyone have 0.9 big? I think that's a larger one or same. Okay, larger one. So this is you see the version. This is 0. Yeah, that's okay. The small, okay, you can see the version either 0.1 or 1.0. Yeah, the small one is 1.0. 1.0. The big one is 0.9. Doesn't matter. The same thing. Only a bit bigger size. Okay. So just you need, later we see the configuration need to be a bit careful. So the pin out, okay, basically there are 7 pin out that is very important. Okay, the first one is the power, V in and ground. But I know that today you giving the power from the USB. So in other case, okay, you may give external power, let's say from solar charger. Okay, you can give the solar charger input to V in and ground. But be careful, actually the whole board is run under 5 volt. Basically 3.3 volt. So what happened? All the input here will go through the regulator IC. So we input, if you can, just below 3.3, like 5 volt. 12 volt is also a bit concerning. So that's why you have to our management later. But in this is for programming. You don't need to worry much because USB or 5 volt coming in 5 volt. So the power, actually the V in is connected also to the V in. Okay. So basically we are giving 5 volt into the board, and then this voltage regulator, it change the regulate the voltage output to 3.3 volts. And then we have digital pins, GPIO, digital pins, or they call as GPIO, general purpose input and output, GPIO. So D0, D1, D2, D4, D5, D6, D7. Then we have analog pin. Only one analog input here. So it means that it has only one ADC. But if you need to measure a lot of analog input, you have to use multiplexer or switch. But they only can convert one digital input or output. But there are many analog input or output, but there are many digital input. And then there are TX and RX. Which part is TX and RX? TX, RX. So that's for UART, Universal Asynchronous Receiver Transmitter Communication Pin. And then also we have SDA, SCL. This is for I2C, but we are not going to use that. But some sensor, there are some module that are communicating using I2C. But in this application, just one digital pin where the data come into serial communication. So there are other pin like D3 and D4 can be used for flash, and D4 D4 also you can check for the general special purpose. Then we have ground. Ground, there are multiple port pin that we can use. Ground here, also ground. Also this is 3.3 volt. This 3.3 volt ground. Same. Actually all they are connected to the same, like 3.3 and then 3.3 here. 3.3 are the same nodes or point. And then we have reset. Okay, reset button to reset the node MCU. Right, so now we go to the setup. So make sure that you have internet. Okay. Now the first thing is you need to do is to download the Arduino IDE. Okay, have you downloaded the Arduino IDE? Then choose according to your Windows or operating.
Same IDE as Arduino, no?
Yeah, the IDE is used to program Arduino. Yeah.
So same program.
Yeah.
Okay.
You have. See. Yeah. You have. You guys have. Okay, already have that one. Okay, good. Okay. Okay. You have. Okay, can install. Make sure that you install the module. I also have installed prior this. Okay, so maybe when you open, you see something blank. Okay, don't worry. So all again, okay? Have download. Okay, so next you need to install the library for Node MCU board. Okay, you go Open the Arduino IDE and go to preferences. Go to preferences, and then you copy this. You have the slide that I have given to you. You copy this, and then paste it here. Your preferences. You paste that additional board manager URL. Additional board URL you paste there. Okay, let's see. You go to the preferences. Yeah. Yeah, press there. Yes. You got? Go to preferences. Oh, this is already Java 8.0. Preferences. You already paste? Oh, okay. Some of you quite advanced. It's okay, no problem. Okay, go to Tools, Board Manager, search for 8. Go to Tools. Then go to Tools. Okay, and then where? What's the code? Okay, go to Tools. Okay, Board. Okay, go to Board Manager. Okay, find ESP. Okay, ESP 8266. Okay, I already installed.
Board manager, right?
Yeah, board manager. Yeah.
I don't have search.
Do you get it? A bit different. Yeah. So ESP, type ESP, PPP, 8266. Yeah, there you go. Press install. Right. Okay. Okay, done that part. Good. Okay, so next you have to connect physically to your node MCU. Okay. Go to node MCU USB to select board, and then select your board type. Okay. Tools, board. Yeah, board. Board here. Okay, I choose 1.0 ESP 12E module. If yours maybe 0.9.
No, done.
Done.
Yeah.
Okay. It can detect, no problem. Let's see.
But it takes some time, like maybe 2 minutes.
Yeah.
To,
Okay. So you should get at the bottom here. Okay, some connected to which COM. Mine is connected to COM3. See your port COM3. Choose COM3. Everyone okay? Anyone? Connected? Yes, okay?
Yeah, it's in download.
Oh.
But her one is have been installed.
Okay. Okay, still downloading the ESP8266. Okay. It's okay? You okay? Huh? Well, can I see you? Okay. Okay. Yes. Itu correct module lah. Okay. And then which com? Com 8. Okay, com 8. Okay. So the port com number will supposed to automatically appear. Like I connect myself com A3, some com 8.
I don't get the port. Should I select something here first?
Yeah. You select that. No. That one. 1 point. Yours is 0.9. 0.9.
0.9.
It says not connected.
No, it's connected.
No, here it's not connected. Again, can you unplug again? Okay, can you find the port? Okay. Okay, come 3, yours. Okay. So you should get that com 3. For example, I got you guys okay? Okay. So you should get that notification port should appear automatically. Your bot should automatically appear. So okay, done that part, selecting and then the COM port. The next part is we want to test the whether our bot is working or not. What we're going to do is to turn on and off the blue light. So there is a blue light on board. Okay, if you go to the codes, the Google Drive, there's a part of codes, and then you can copy the code. Okay, you can copy the code and then just paste on the IDE.
So we pick any one of them?
Sorry?
We just pick any one of them?
No, blink. Number 1, blink. No, not that one. There is a blink. Okay, there is a file named blink. Yeah, open that. Okay, open that blink and then you copy paste. Okay, so you can try. You can test this. Okay, verify. You could perform. Just verify first. Okay, verify if the verification is okay. So there will be it will prompt. Okay, something will prompt out. Yeah, like this. But don't worry about that. Okay, done compiling. So red doesn't mean error. So if done compiling but red notification, that's fine. Can you compile?
Compilation error.
If there is a compilation error, means that we need.
It's an error in the delay. Maybe the dot?
No, that's okay. Or you missed this. You didn't copy it fully. You missed it. How do you call it? This one. Chief. Here you go.
The last one. Yes.
Okay, so can you repeat it? Delay. Yes. You try compile. Okay. Okay, if you done compile, you can upload sketch and then you upload. So it will take some time. You try upload.
Excuse me, sir.
Yes.
Ours is not there. The port is not discovered.
Oh, okay. Have you put?
Yes, I've pasted the link there.
Which computer? This computer?
Any of them.
Any?
Yes.
Try. Can I see the?
It only blinked 3 times and then finish.
No, it will blink 1 second. No. Oh, you have to hard reset. So it blink every 1 second.
I see.
Is it?
No, it was working, but I was moving this.
Yeah, hang on.
Yeah, I was just moving this maybe.
Yeah, hang on.
I'll just do it again.
Okay, how's yours? Can I detect the port?
Yes.
Go to tools. The port. Oh, it's not. It's not enabled, eh?
Yes, even mine.
Have you? Man, you have to put the node MCU first. Have you? It's okay. Have you select the ESP node module?
Yes.
Yeah. See, not that one. Board manager.
Yes.
Board manager.
Go. Hang on. Let me see. Can you move here? Only once?
Yeah, it will work for 17 seconds. Then you have to repeat and download it again.
Oh, really? Maybe the code name is different.
Yes, the code name. So
No, I mean the board name. So you can because you are 10.9.
go from 0% to 100%, and then it will blink every 1 second. And after that, when it's done, it will stop. So you have to repeat. So like this.
No, it's
What works? Now to work. See?
no. This
Yes,
is
see?
this is writing. 18,
8, now it's
25,
working. See,
30. No. This is just writing. So you need this to be 100%.
Yeah, but the blink, it's blinking here.
I don't know. That's blinking because it's writing the
Writing,
data.
okay.
We have to wait until 100%. Okay, done. Okay. Supposed to the uploading done. Done upload. So this supposed to be blinking.
Yeah, blink, right? It will blink only once.
Not this one. This one. This is an onboard LED. This.
Maybe I have to remove this one.
No, if you remove it,
No, I remove this one.
yeah, try to remove this one. No need actually. Can you? This is 1.0.9.
I think maybe.
Can you choose a different Oh, this is 1.0.9. Can you choose 1.0? Okay. Let's see. No, because you see the issue here. Let me. I think the issue here is
I want me to choose 1.0. 1.0 now.
Can how do I? Okay, let's see. I don't see the problem here. So when you try to install, this is ESP8266. Snowboard here. Sketch. Tools. What? This selecting here. Have you installed the
same result?
Is that the same as ESP32?
Yeah.
Is that the same as ESP32?
Yeah. Install. Yeah. Try to install Git. Is it possible if I use this other? Try.
What about you? Because it's lighting there, it's fully connected. This one done? Okay. What would be?
It's compiling.
Are you sure it's 1.0? Then how do I know my own?
Did you have the device manager? Can you open the device manager? Who's the device manager? Okay. I don't know how.
I think it is the ESP version.
Yeah.
Because for him, you are selected 32 and then it is discoverable.
Which one? ESP?
Yeah, it is using the same both the same ESP as mine.
Oh, I think this is quite.
So you are changed to ESP 32 and it has worked.
Oh yeah, really. This is not exactly not MCU. So wait, which port do you select? Oh, I noticed this is not exactly. What?
So you can search for ESP 32. Click here, select other boot.
Yeah.
And search for ESP 32.
ESP.
ESP 32. This one.
Still. Huh?
Yeah, so yes.
Yeah, I noticed this is a bit different. Where do you get this module? Looks a bit different. This is not actually not MCU 100%. But anyway, good to know. Okay, we try. Oh, this is more like.
So it's now connected. Not connected.
Not yet. Just try still downloading the module. Yeah. Okay. So good to know. Some of the board is not exactly. How about you? You. It's okay.
No sense.
Can you get the blinking? Anyone get the blinking? Or you get the blinking? Do you get the blinking? Oh, it's a bit okay. Maybe your board you choose ESP 8266. No, not MCU. Choose 8266.
It's ESP 32.
Yeah. No, which board you select? ESP32. I mean, this is not. Yeah, ESP32. But have you select the correct board? Okay, have you program? Have you program? Okay, and then did you get the blinking? No. So yours?
We use the 1.0 version and upload the code, but it's not running. So maybe we're gonna try with the 0.9 version.
Okay, try it. Yeah, sorry. They want, yes, because they are using ESP. Can you give me that board?
Yes, sir.
I try on my computer.
We're using 1.0.
It's okay. Give me the cable. Oh yeah, push. Let me try on my computer. They are selecting 8 to not MCU because the board looking a bit different. But anyway, you should get something like mine. Okay, it's blinking every 1 second. Okay.
Upload from there or using the arrows, same thing, right?
Yeah, simply. Okay. Yes, I got working. Okay.
Maybe the cable
I don't know. Okay. Is it a cable? But can you detect? I saw this programming. No. Still uploading. Wait, can you put? Oh, very strange. But I got. Can you connect? Because successful. Can you take?
Oh, sorry. Your code is still running.
Sorry?
Your code is still running.
Yeah, because you didn't.
So, how many times did you do?
Yeah, it's good. You press. So you settle. So the different. So maybe you have to use different board for But is it blinking? Is it blinking?
Yes.
Oh, okay, nice. You're blinking. So that I know the issue, but this one, have you upload or what?
No. Yeah, we tried uploading, but it's not working.
But it's blinking.
Your code is still.
But you have override, right? When you override,
I guess so.
it's working, right? No, because you have already override.
Change the delay time and faster.
Serial port COM 3. No. This is cannot detect the COM. You cannot detect the COM. I mean, you try find the COM.
Check out the device manager.
No. My port. You see, port is not there. I think try this cable.
Yeah, cable.
Yeah.
It's very different from what because I understand how this works. We pick the COM, okay, and then we have to pick this one, right? The node. ESP.
Yeah. Correct.
Okay.
Yeah.
So this is for different type of boards.
Yeah. This board has ESP on it. Has ESP.
So if I pick the wrong board, it will not work. But if it's writing, that means it's okay.
Yeah, it's okay. See, I think your how about can detect? Hang on. Also cannot. What happened? Suddenly cannot detect.
We can figure it out. Can you check your code?
Yang tu tak nak blinking. No. What kind of board do you choose? ESP32. Tu blinking? Huh? Okay, so some board is not actually not MCU. Not I'm sure configured as not I'm sure. Never mind. Never mind. Okay, some board is configured at Node ASP at 266. So different. We have different manufacturer here. Okay, this group settle. Can you detect? Can you detect the board?
Yeah, it's in COM3.
Okay, COM3 fine. Okay, COM3
connected.
Nice.
COM3 connected. I can write, no problem. But it's not working.
Not working.
As intended.
Okay, let me try on my.
Yes.
Okay, can I have my cable? Let's see.
Yeah, I don't know.
Is that code same as yours?
A bit different, but I think no issue.
So if I don't know the number, then I just like
Cannot detect, huh? Okay, COM4.
Just like I'm doing this.
No, don't do the same. It will not be the
It will give you everything.
So it's uploading, huh?
Yes.
Yeah. It's not. It's not.
I have to keep pressing?
No. It's supposed to be working, but it's not working. Okay, let's do something else.
Okay.
That for your board. Okay, let's choose ESP board. Says the Lolin. Lolin.
You see this LED. Two things. Then from this You want to do Sorry?
Try different baud rate for your board. I hope. It's bit different. Where do you get this module? Top one. Oh, really?
A good thing, actually.
I think maybe there's something we have to figure out.
But I cannot wait. Guys, at the back, do you have solved the issue? Do you have the solve?
No, not yet solved.
They have the same board as mine.
Lolin, you have the same one. You cannot detect your board?
So detected at all?
Because in top one, they have this big and then the smaller one, right? So you get the big one.
Small one.
And then you get the small one. But mine can detect. Maybe you have to update your IDE.
No, this is the latest one. 2.1. 2.2.
And then the ESP update. Okay. Which group still haven't solved the issue? 1 and 2. You okay? This group okay? This group okay? Back okay? So what? Okay. Meanwhile, I think we have to move on. So the group that haven't solved the issue, because this I think the board issue compatibility. So you can combine with the group that has running, and then you see because we have to move on. I hope that you all have done this, right? You have done this, the part, additional board URL, done. Okay, so we have to move on. Okay, mine is already done, so we have proof. Okay, that the code run the program and then do the blinking process. So we have to move on to the next module, which is the humidity and temperature measuring sensor. Okay, while you are at it, let me explain. So this is one example of Node MCU where it integrates with many kind of sensors. See, for instance, the 2 DHT, because this DHT sensors is used to measure the inside and outside temperature and humidity of the beehive. Then it has a load cell, measuring the weight of the hive, and then there are other sensor here, which is bee count. Okay, we use pair of infrared sensors. Then we use the logic, and then the output is sensed by the Node MCU. Okay. Then the data is all pushed to Firebase. Then using web app application or Android, we can see the data. But today, we simplify the application, only use one DHT and using Google Sheet. You can read further this work on wireless English B Hive monitoring system. Okay, so how many of you have the blue one? Okay, 1, 2, and how many have the white one? Okay, so they are both DHT, which is temperature and humidity relative humidity sensor, but this one is the later version of this.
Which one is used?
This is the latest one. But anyway, it's good. You see the pin is different. You look at the board. For blue one, this is the VCC, data and ground. Data is in the center. For this one, I think the data, the board missing. This is the data on the right, VCC in the center and ground on the left. Okay, on the left. So be careful when later we going to configure. So it is actually a module. DHT22 is a combination of relative humidity sensor and temperature sensor, and that is it is combined together to measure both environmental parameters. So it has usually it has 3 or 4. Usually on the sensor itself have 3 pins, but the output here 3 pins because 4 pins on the casing here. You see there are 3 pins, 1, 2, 3, 4 pins. But on the board they will use only 3 pins to connect to the mononode MCU. So those are the specification. VCC the power, not more than 3.3 volt. Okay, and then the data will transfer through node MCU and DHT, and then the ground. So the has 2 main components. The first is measuring the humidity, is basically based on capacitive sensor. So it has 2 electrodes, and then in the center there are insulator which is sensitive to the humidity. So when the humidity increase, basically conductivity increase or resistance go down, or the total resistance. So it is sensitive to humidity, but the thing is that the curve is non-linear. Okay, and there's another part where the component to measure the temperature, which is the NTC. Looks like this, no NTC thermistor, negative temperature coefficient. You remember NTC in our class, or we have discussed on working principle of NTC. Basically, the resistance of the sensor decrease as the sensor increase. NTC is good to measure very small resolution. So both basically both capacitive sensor to measure the humidity and the thermistor to measure the temperature is combined together, connect together to a 8-bit microcontroller. You cannot see at the back. Actually, it is at the back. Here, if you open the casing, you see this. At the back, there is a 8-bit microcontroller that measure the analog output. These 2 sensors, the original output convert environment parameter into analog, and then that analog is connected to the 8-bit, and then it measure, and then it convert into the data. Okay, data, series data, series that protocol with pulses sent to the microcontroller. So the thing is that when using this sensor, you have to give some interval, okay, like 1 second minimum, but save 5 second minimum before you make another measurement, because the data sent between the DHT to microcontroller is in the form of digital signal, pulses of digital signal like RS232. So the data is sent pulse by pulse. So need some time to convert the information. Okay, both temperature and humidity data is sent into the digital signal in pulses to the microcontroller. So you need to convert the data one by one. I mean, it need to convert. Okay, it receive the information, get the binary value, and then convert the data. So it need some conversion time. So when using DHT22, you need to consider giving some delay. Alright. Now let's go to the interface. Okay, so you see, if you have DHT11, those are the pin out, but DHT22, these are the pin out. Be careful, if you wrongly connect, it will become hot. Okay. Now try to connect. We are connecting to D6 to D6 data to D6 pin into the data point, connect to the D6.
Can we connect it to the 3 volts?
And then connect 3.3 volt, yeah. VCC to 3.3 volt and ground to ground. But you have to be careful if you will use DHT11, these are, okay.
Mine only has 3 volts.
3 volt. Oh, it's okay.
It's okay?
3 volt. Okay, have connect? Right. Okay, next, you will need to download the library. There are 2 ways how to download the library. First one, we get all the library from Adafruit, we go to the GitHub, but I prefer if you go to the sketch, include library, manage library, search for DHT sensor library, and then install.
Sketch.
Okay, sketch. Okay. Sketch. Include library. Then we will go this library manager here. Find DHT, search for DHT sensor library, and then install. Sometimes you will get this prompt. You say that the library DHT sensor needs some other library dependency currently not installed. Adafruit, yes, install all. Do you get this prompt?
Yeah.
If you get this prompt, install all. If you don't get that prompt, you also need to search for Adafruit unified sensor and then install. But usually you will get this prompt. Okay, you search for DHT sensor library, install, and then you get this. You try.
DHT.
For EST what?
Yeah, DHT sensor library there. This one, install this one. Install all. Okay. Yeah, good. Okay, that will install. Did you get the prompt? Install all? Okay. Got? If you got that, now go to the Google document, Google document link, and find the code for DHT22 serial monitoring.
Serial monitoring, sir?
Yes. And then
we upload,
and then you can paste. You paste that. Now, the thing is that I are using DHT22. So if you use DHT11, change to the DHT11. Usually don't.
Mine is DHT11.
No, just change. This one, DHT11. Don't worry. But make sure the connection, the pinout connection is correct. I hope that. Okay. So then upload. So you.
It's moving.
So mine is uploading. So the solution for guys who cannot use the current board, I suggest you get the 1.0. Okay, try to get the.
Didn't like this one.
Okay, now mine is done uploading. You may not see anything, but you go to tools. You go to serial monitoring. Okay, see at the serial monitoring, you get this output. So the code actually, they have initialization process, define the pin number, and then define the DHT variable, then the setup, and then this is the code where it runs in loops. So you see, I put there 2 seconds. So wait for the sensor to, no, but it looks like faster. Okay, give 2 seconds, and then here, so it will fetch the data from the sensor. So there are 2 if else. The first if the function is call function is non-temperature and then is non-temperature humidity, which means that if it return not a number, none is none, not a number, so means that it returns something gibberish.
After we download the program, it says hard reset. Yeah, every time we have to reset.
Usually don't. Usually auto. Yeah. So yeah, it returns some gibberish. Where's the board? Oh no. Okay. The pin out, do you connect properly? D6, Okay. And then can I see? See, I told you if you use DHT11, change that to DHT11. One, and then re-upload because you are using DHT11.
Is it okay to download all of these libraries to not affect the program?
Only take your computer memory. So mine is running. Everyone, how about everyone else? Okay, go to the senior monitor. You get that value. Now it's measuring 56.2%, 22.3. So to check whether this is working or not, so I bring my hair dryer. Oh, sorry, wrong one. Not too fast. You see whether the temperature, okay, 25, 27, slowly increase, 29, 31, 34. Okay. So have you done successfully connect? All right. Yes.
It is reading, but it's giving me
Gibberish. Oh yeah. Okay, nice. Interesting.
So is it compatibility?
Try change this one. 11. You guys solve the issue? No. So what's the problem?
We're not sure, but the laptop works, so
Her laptop is fine, so she's working on it. But our laptop.
I think the port has to be some configuration at the setting level. That part have to, discover a little bit. Yeah. But it's good to know because
Your blue or blue? To go up.
Still giving a.
Yeah, still.
Okay. Maybe. Okay, change the baud rate.
The bit one?
No, baud rate.
I thought this would be the problem. Maybe
11.
smaller one.
See? Change the baud rate. You change the baud rate. Baud rate to 11.115.200. Okay, if that doesn't work, change the baud rate. No, it's okay, right?
11,000.
11. So now yours is okay. But I think the blinking was also because of the baud rate. I don't know. Hey, okay.
It's showing third to read from DHT.
Sorry?
Third to read from DHT.
Interesting. Oh, you are using what you call hub?
Yes.
Can you avoid using hub?
You want to check?
I don't know. Yeah, hub. You are using hub.
Yeah, because this one has only type C.
Yeah, I know. But blinking was okay.
Yeah, blinking was okay.
Interesting. Can you hard reset?
This way.
Fail to save it. Connection? Okay, why?
So this is the signal.
Signal in the center. Right. Ground?
Then ground is here.
How about? I'm not sure, but because you have this hub, I never experienced using hub. Can you direct connection?
You can.
Okay, this one settle. Okay, working. Yours okay? Fail to detect. This is new. D6 betul? Macam lainnya. D6. Ah. 3.3 apa macam ground you connect. Reset. Nampak. Cuba reload. Cuba. Okay, good. Okay, that's what done. So that's group done. So this one still trying. Okay, if you got DHT working, so we can move on to the next. Maybe I don't not sure. Dia punya baud rate, can you change? I don't know. Maybe cannot be that fast ke?
So this IoT is supposedly we can connect to the cloud.
Yes.
So what's the difference between this and Arduino in terms of other applications? Like can we use it for other instrumentation?
Yeah, as long as you know what you are measuring.
Because right now we have another project that we have to use MATLAB to program to control water tank.
So you connect the system. It is not usually connect to MATLAB, but they are like simulating. But usually MATLAB is not used to connect. But okay, you can find the. Okay. How's it now? Compiling.
Failed to read.
Still fail to read.
This chip has more memory than Arduino. So it can think better than Arduino because it has more memory.
That's right.
This one I'm not sure.
You want to try? Play around.
Okay.
Yeah, it's increasing. Yeah, it's increasing 24. It takes some time. So remember, in real life, sensor will have response time. You cannot expect that give input suddenly change. It has response time. So now you see response time concept.
Still going down.
Still not.
You want to try?
I only have one set. Which can? How about you try mine? You try mine if you want to, but you have to choose. I'll give it my. But you have to choose Node MCU 1.0. Okay.
Just go back. Maybe it takes some time.
Kau boleh juga. Good. Apa dia punya issue? What's the issue? What was the issue? Don't know. Just plug.
Because I copied the wrong PHP file.
They don't have.
Two. Okay. Yeah. So of course, if you use 11, you put 11.
So this will inside the it will define
11.
11.
It's a bit different in terms of the rest, 8-bit microcontroller. So I hope that it can be okay. Okay.
After I pull it off, it's stuck in the same place.
Stuck in the same place. You pull and then you put back. No, you cannot. You have to reset. Let's reset. Yours okay. Good. Okay, very good.
This is version 0.1.
1.0. 1.0. No.
Showing error still.
What error?
Timed out waiting for packet.
Can I see the board? You choose 1.0?
Yes.
And then baud rate. Can I choose the? Can you go to the setting?
Oh, I have to change back the settings.
Yeah.
So yeah.
What package you use?
I'd put one for ESP packet.
Oh, okay. Still not.
Just reset the serial monitor and it will work again.
Yeah.
Only the one.
Yeah. So you have.
I think you and yours is up.
And I thought I didn't bring it.
This one is already defined. It has good Python.
Sorry?
It has Python. Is it Python?
Yes. But because you are using iPhone, Apple.
Still the same error.
Same error? Maybe because you are using Apple but yeah, can you test?
That's it.
Okay, let's wait for that group. So this working. Have you changed the link to the library. Not sure, but that guys from sorry.
Here it shows negative. Meaning this is a minus, this is signal, yeah. It's different from what you had shown earlier. So I think we should change.
Different.
Yeah.
I mean,
it's the same like that one over. If you see this?
Yeah, different from this one.
Yes.
Yours?
Yes. The signal is the output, is the far left, far right.
Oh, did that no marking?
Yes, that's negative. There is negative and S. S is for signal.
Negative.
And ground. And S is the signal. That means the middle one is the positive. Let's try that.
Yeah. But wait for your friend there. I'll give you my version. See whether it's working for him.
The one here is 2-2. The red one is
2-2. This one is 11. But even some of the 22 here has no marking. It's okay. Okay, wait until you. Is it okay? Or still uploading? Should take some time. Yeah. Yeah.
I didn't have group before, no?
Yeah. Carry on.
Do we have to write the group number here?
Yes, yes. Okay, so this is group 1, group 2, group 3, group 4, group 5. Group 3. So group 1? No yet.
Where's group 1?
So this group 1.
Okay, group 2?
Group 2? No. So you group 2.
No group 2? Oh.
You group 3, yeah?
Yeah, group 3. What group?
You group what?
B group.
You take, it's okay, take, that's a number. Okay, you take number 2.
Okay, we take 5.
5, okay.
Yes, it works now. It works.
Now what?
Yeah.
Finally!
Yeah, so this is the signal.
Oh, so the issue is just the pin, right? Because yours has no marking. Okay, so just this one?
This one still showing this. It's okay.
What's
rate is the same.
22?
This is yeah.
Clear output?
No, is it being gibberish? Ground is ground connected? Is the ground connected? No. There's no ground here.
I don't.
This is ground.
He was using there.
There's ground there. This is 8266.
Oh, okay. I think.
Let me also try and see.
Data is 6. Is somehow. How? I think.
Usually
I mess up the connection. Oh, sorry. I mess up the connection.
Gibberish comes in the ground is unstable.
What's the difference?
Hang on.
Finally.
Careful. Okay. So it's supposed to be. D6, right?
At least 6, yeah.
Okay. Should be okay now. Clear output.
Yeah, now it's reading.
Getting Okay. Okay. That's fine. Okay, so all as working, so a lot of interesting findings, like for example, different kind of bots and modules. Okay, slowly you can get the idea. So we need to move on. Okay. Now we are going to set up your Google Sheet. Okay, so the first thing you need to do is to go to your Google Drive. Okay, pick an account. Okay, like okay, pick go to your Google Drive. Okay, go to Google Drive and then create. You can directly create the Google Sheet, but better you create a folder. Okay, like create a new folder. That IoT underscore application. Whatever you like, the name that you familiar or you prefer. Then you create the folder. So later, if you want to find it quickly, you can go to the organize and then add star. So later, if you open here, you go to star. Okay, you can see this is the folder that you star. Okay, then here you can open there and then new. Okay, Google Sheet. Create a new Google Sheet. Okay, and then you name whatever like DHT32. Oops. Sensor data. The name. Okay, so create the name, like for instance, okay, like just now I did DHT22 data. This one is 3211 data. Then you look at the URL. So these are the link to the Google Sheet. But this one, the highlighted part here, so this is your sheet ID, Google Sheet ID. So what you can do, you copy that and then, for example, you copy that Google Sheet ID. Okay, in this one, this is the Google Sheet ID. Oh, sorry. This is the Google Sheet ID. You copy. And then paste here. Then this is Google Sheet ID, just leave it there. Google Sheet ID. Okay. So you have, okay, copy your Google Sheet ID. Next. Okay, now you go to the app script. Go to app script editor, or sometimes, okay, depend on the version of your Google Sheet, the app script is under the extension. menu.
It's Google Sheets, Doctor?
Yeah. But like mine here, extension, there is an app script here. Do you see that app script? But I forgot to tell you to do this. Okay, we going to use 4 columns A, B, C, D. Can you write down column A on the top, date, and then time, temperature, humidity? So here, date, time, temperature, humidity. Okay? Are you okay, Yosh? Can't find Google Sheet. Go to Google Drive.
Yeah, this is Google Drive.
No. You just new. Google Sheet there. Yep. And then next, you copy the Google Sheet ID. Google Sheet ID after this D slash, then 1SJ. Mine is until here, XG. That is the Google Sheet ID. Copy that. Put it somewhere. Put on the text somewhere. Okay, then next go to app script. App script maybe go under tools or maybe under extension, depend on but I think the latest one is under extension.
App script?
Yeah, extension, app script. Click that. Then you will see this. And then the title of your Google Sheet. For example,
Google ID first.
okay, extension, app script. Okay, hang on, wait it until it load. Okay, then give the same name. Same name. Mine is the copy -2 sensor data. Mine, and then give the same name. Same name as your Google Sheet. Rename. Okay, this is on the app script. Then you go to Google Drive, the resources, all the resources. Find the app script codes, number 3 here. Can you find the code? Okay, you go. This is app script. Open. Okay, copy all this and paste. copy all this. And this. No, sorry. Do you manage to copy the code?
Yes.
Hang on.
But there's a different code.
Sorry?
Different code that no, it doesn't have bar or whatever.
Control all. You copy the codes and paste. Yeah. Do you get? Can you manage? No. Who has problem?
Which code?
App script number 3. Number 3. 3. Yes. One there. But maybe you have to download it first. Can you copy directly there? No, not on IDE. Copy on the app script. Yeah, there. Yeah, copy here. But first rename here same with your Google Sheet. DHT11 data. No, must be the same.
DHT.
Yeah, must be the same. Okay? Now, there are 2 parts here on the Google Sheet ID where you have to change. I think 2 parts or 1 part. Let's see. Okay, got it. You have to paste your Google Sheet ID here. Okay. So your Google Sheet ID here. And then paste here. Paste. Is that done?
Okay, next we do deploy or?
Hang on. We wait for everyone. So all the data later will come from IDE, we call the program.mcu, and this app script will write the data on your Google Sheet. So the temperature will be written on column C. Here, temperature will be written on column C, and this is supposed to be temperature, and this is supposed to be humidity. There's a typo error here. So if you go to the Google script, okay, here is temperature written in column C, and humidity written on column D. But you need to paste your Google Sheet ID. And then the name must be the same. Okay?
Yes.
Okay, then we have to go next. Then you have to deploy. You click deploy new deployment. And then select type web app. Deploy, new deployment. Okay, select type web app.
Description. Would you just write the
Description, you can type testing or testing. It's okay. Testing DHT data. Okay, then this is the email that you choose, and here you have to allow anyone, because you're going to give Arduino IDE access, okay, to the Google Sheet through app script. So that's why you have to put anyone. Okay, and then deploy. So they're updating the deployment.
authorized access?
Yes. Then you have new deployment. Then you have to authorize. Okay, authorize that. Okay, using yourself. Okay, authorize. Okay, then you choose your account. Okay, allow. Allow. Let it allow to use. Then you see this web URL. Okay, and then you copy this web URL. Copy. And then put it somewhere. Okay, I prefer to put it here. Another one. Put it here.
And Word or Notes?
Notes, yeah, no problem. Words, notes, no problem. Okay, so basically we have done that part on the Google Sheet. So
And then you have done?
Here we have done.
Right, so I click done.